work with fractions. We add fractions, we subtract fractions. And to be able to do this, we need the same exact denominators. And that was the key idea, because procedure of dealing with fractions is completely different when you add or when you multiply. Multiply, you just factor and cancel, but when you add or subtract, well, you need to produce the same denominators. That's the difference. So let me take a look at one exercise in here and come up with the result when I add a pair of fractions. So let me try problem number 65. Here we have one fraction with numerator 2x plus y. And its denominator, I'm gonna factor out. Actually, there's nothing to factor out, so it's y minus 2x. So first fraction is here. And the second fraction, I will try to factor its denominator. This will be y minus 2x, the same factor as denominator of my first fraction. And then, since you have y squared, you can use y for the first place. And then the last place is 4x squared. So I'm going to use minus 2x times minus 2x is going to be plus 4x squared. And on the top is 3x squared plus y. So I just keep it the way it is. So now I need to produce the same denominator. Again, I'm doing exercise 65. And the same denominator must have everything. Means that it has to have and y minus 2x. And again, y minus 2x, because it looks like the second fraction has its denominator that contains denominator of my first fraction. So now here's my goal on the bottom of second fraction. So I need to have y minus 2x multiplied by and the top and the bottom of my first fraction. So now I need to only work with numerators. Now I need to carefully multiply and see what is going to come out. So I'm going to multiply for the first piece, for the first fraction, 2x by y, and then 2x by negative 2x. So it'll be 2xy. And then we'll multiply positive and negative, so it'll be negative 4x squared. So this is my start, and now I go for the product of parentheses with the second term with letter y. So let me try to multiply by y, so we get a positive y squared, and then y times minus 2x will be minus 2xy. And then I can cancel the 2xy and minus 2xy, and that's great. So what else do we have here? Well, looks like my numerator can be canceled. Oh, can be factored, isn't it? Because it's actually y squared minus 4x squared, or minus 2x to the power of 2. So I can factor this, and notice that when I factor it with y minus 2x times y plus 2x, then one of these factors is exactly the same as we have on the bottom. It's also y minus 2x. So I should go ahead and cancel that y minus 2x, and this will be giving me the answer, which is whatever's left over, y plus 2x divided by y minus 2x. I need to write x a little bit more careful. So this is a lengthy exercise, and I think if you'll be able to redo the same thing over weekend yourself, that should be good enough for this section, because it looks like problems get pretty tedious, and I don't think we need that, but I guess just one exercise of this kind is good enough to try to look at. So I'm going to move on to the next sections, and I skip section 6.4, so-called complex fractions, and move to solving equations. Equations is what is very popular in math classes. So I'm going to section 6.5 that wants us to solve equations with denominators. And it turns out that to solve equations with denominators, I need to clear those denominators. So if I try to look how they suggest to work out example number 1, the equation that has denominators of 5 and x, well, what they do is they use 5 multiplied by x, that common denominator, to multiply on both sides of this equation. And when they do this, notice they end up with equation without any denominator at all, because this denominator cancels. So when you solve equations, the method is totally different, because you can clear or get rid of your denominators. And if you don't have denominators, well, the equation becomes much nicer. And that's the only thing that we need to keep in mind. So let me do some problems here, solving equations. So let me try to start with a practice where, like, starts with number 13, where they have equations with various denominators. So I'm looking at exercise 13 that says, how about 1/5 plus 8 over x? 8 over x. So we're gonna have this equal to number 1. And to solve this equation, all I need is to find same denominator. It looks like we have 2 denominators, 5 and x. So if I multiply by 5x, my right side and my left side of this equation, then these denominators are going to cancel. And if 2 expressions are equal, then if I multiply by whatever, both sides of this equation, nothing changes. But what is going to change is my denominators are going to disappear. Letter x here and letter x here. So look at what we get now. This is going to be just x, which is left over, plus 40, 8 times 5, which is equal to 1 times 5x, which is just 5x. And this equation looks much nicer. There is no denominator. And that's the key idea in solving exercises in this section. Just make sure that you clear your denominators. So you have 40 is equal to 4x, and that's why x should be equal to number 10, because 4 times 10 is 40. So I produced much nicer looking equation right away after I rid of my denominators. Let me do number 25. Here's another exercise that has denominator, but it is a very nice exercise because denominator is the same, it's just a letter x. So I have x plus 1 over x. And then we subtract from it x minus 1, also divided by x. And this is equal to 0. So let me try to do the same thing to make x to disappear. So I'm going to multiply by x my left side, each piece I distribute over, and also multiply by x the other side. And this way we no longer have any denominators, because the point of this multiplying by x is to make sure that you don't have denominators. They cancel. So what's left? Looks like x plus 1 is left. Also minus x minus 1. Notice that I have to subtract entire x minus 1 here because we subtracting the whole fraction. And this gives us x plus 1 and then minus x and plus 1, which is equal to 0. So what do I get then? Well, looks like the x's are going to cancel, and you end up with something that is not correct. 2 is equal to 0, and this is not correct because 2 is not equal to 0. So that's why you say there is no answer, because when you start to solve this equation, you ended up with something that makes no sense. And no solution here they shown with, excuse me, the symbol which is called empty set. The circle crossed out, it's called empty set of solutions, means there is no answer. Instead of just using words to write no solution, they decided to save ink and they put empty set. Well, sometimes this is the case, and it's good to realize. So whenever you solve an equation and ending up with something that makes no sense, you say, no, this makes no sense. Which means that solving this equation in the first place was a bad idea because it has no solution. So you can't solve it. Now that's all we really have here. So let me do one more exercise. Exercise number 29. Now the problems get more involved with denominators. So I'd like to solve one exercise in here. So x plus 2 is on the bottom. Then I also subtract, actually it is equal to number 1. And then it's minus with the fraction that is look complicated. But notice I can factor denominator of this fraction with x plus 2 times another x plus 2, can I? Right? Because we have x squared factors with x, and last number 4 factors 2 and 2. And notice that those factors usually repeat because I already have this same factor in the denominator of my first fraction. So I need to decide what is common denominator, and looks like it being indeed x plus 2 times another x plus 2, right? Like we have on the bottom of first fraction. So I'm going to have to multiply by x plus 2, this product, my left side of equation, and the right side. Notice there is also minus 1 here, plus 1, so it will be multiplied by x squared by that entire denominator that we already have here. I can distribute this plus 4x and plus 4. So when multiplying this by entire fraction, every single term of it, my denominators are going to cancel, and that's the whole point of doing it. So what's left? Well, looks like we just copy remaining parts after we cancel. That's x times x plus 2. That's what I have on the left side. Now on the right side, I have 1 multiplied by that x squared plus 4x and plus 4, right? And then we have to subtract, and then again, just like in the previous problem, when I subtract, I need parentheses to make sure that everything is correctly subtracted. So I left with this numerator, so I have to make sure I put a minus, so I subtract this numerator. And we're gonna have equation to solve, so I distribute x, so I get that stuff on the left side. Now when I start to distribute number 1, I don't really distribute anything, I just copy this x squared plus 4x and plus 4 the way it is. And then I'm gonna make both terms inside the parentheses negative, because I distribute negative. And then what I can do is subtract x squared on both sides. Notice that I have x squares, but if I minus on both sides of my equation x squared, it'll go away. And that's great. So what's left over? Well, there's little equations such as 2x on one side, and then 4 minus 3 is just x on the right side. And also 4 minus 2, which is 2 next to it. So the equation gets nicer and nicer, and I think we're pretty much done with it, right? So I just need to subtract x on both sides and get the result. On the left side, we have x, on the right side, we have number 2. And that's it. So I solved another equation. Again, these exercises are lengthy and involved lots of manipulations with those denominators and factoring, canceling. And that's why I guess I want to introduce you with this type of procedure. I'm not going to put this on the test because this is really a little bit too much, I know. But you should be able to see it in this class, and then when you see it again in the next class, in a college algebra class, I'm sure you will be able to feel a little bit better about this. And this is the whole point. So I guess I want to stop at this stage and let you go, because we're actually having a spring break on Friday, Saturday, and Sunday. So it's Easter break, and you don't get to experience it because you don't have a class on Friday anyways, right? But I guess it'd be fair that I give you no quiz today, because in the spirit of spring break. So before you go, I'll suggest you check the schedule of classes. I remember told you that you can register for college algebra class in the coming semester. And I suggest that you try to register for it as soon as you can, so you don't postpone it until fall, because we're going to do same things as we do in intermediate algebra again in the college algebra. So that'd be good that you're fresh on this material so you don't forget it, and that way you will definitely pass it. So I know you need a little break. That's why I recommended you to sign up for second session. So second session starts in June something. So you will have more than a month of a break, month and a half, and check the schedule. I also teach that class in the same format as I teach this one in the Zoom format. It's called MDC Live. So you can find it. It's I think I teach it at second session. Just check the schedule. So if you wanna do it on Zoom, just same way as we're doing this class. I will also give you a free textbook, so you don't have to buy any books, and I guess that way it's probably nice. So anyways, let me stop to record this, and I'll let you go and have a little bit of a spirit of a